Algebra 2, 3.7b, find equations of parallel lines. Now, if you haven't seen the previous video, 3.7a, or the previous videos for Chapter 3, you might get confused, and there's links to go to those in this video's description. We can write an equation that contains a given point and is parallel to a given line. 3 steps. We find the slope-intercept equation, y equals mx plus b. We identify the slope m, and then we find the point-slope equation of the line with that slope and containing those x and y coordinates as a point on the coordinate plane. I'll explain. So remember, this is the slope-intercept form of an equation, and this is point-slope, okay? You can see the x1 and y1 values. You can see the slope there, all right? So the first thing we're going to do is put it in slope-intercept. So we can write the equation of the line containing the point -1 for x and 3 for y, and parallel to the line 2x plus y equals 10. First thing we're going to do is find the slope-intercept of the equation. So this equation has this 2 right here, and we need to get it so the y is isolated, don't we? So what we can do is we can use the addition property of equality to add a negative 2x to each side of the equation. That's going to eliminate this one, turn it into a 0 pair. Then we have y equals a negative 2x plus 10, because the x goes before that constant 10, which is the b, see? We know our slope is the coefficient of the x, it's -2. Now we find the point-slope equation. Remember, that's this guy. And we plug in our values, this x of -1 and y of 3, into this equation with that slope of a -2. We get y minus 3 equals -2 times x minus a -1. And when we subtract a negative, we add the opposite, don't we? So we're going to get an x plus 1. Now we can distribute that -2 to the x and to the 1. We get y minus 3 equals minus 2x minus 2. Now we can use the addition property of equality again to isolate the y. So we're going to add 3 to each side of the equation, create a 0 pair here, and now we have y equals -2x plus 1. -2 plus 3 is a positive 1. Remember, to be parallel, we need the same slope m but different y-intercept b values. So here's our 2 equations. The first one said y equals -2x plus 10. See? And this one says y equals -2x plus 1. They have the same slope and different y-intercept b values. So yeah, we did it right. And this is our equation of the line containing the point and parallel to this line. See? Let's try it again. So we're going to write an equation of the line containing the given point and parallel to the given equation. So here's our given equation, and here's our given point. The first thing we need to do is put it in slope-intercept form. So what we're going to do is isolate the y. We're going to take 8 away from each side, or you can look at it as adding a -8 to each side. That's going to create a 0 pair here and eliminate it. Now we have 2y equals a -8x plus 6. So remember, in slope-intercept form, this -8 coefficient and x come before the constant, okay? Now we can divide each term by 2. Now, dividing by 2 is the same as multiplying by the reciprocal of 2 as 1/2. So you may use the reciprocal of 2 as a half and multiply each term by that, or you could go quicker and just divide each by 2 because there's no fractions in here. Using the reciprocal is easier when there's fractions, isn't it? So now this becomes our buddy, the invisible 1, and we have y equals 8 divided by 2 is a -4. -8 divided by 2, I should say, is a -4x. And 6 divided by 2 is a 3. So that's our given equation in slope-intercept form. See? Y equals mx plus b. Y equals mx plus b. All right? So we know our slope is -4. It's the coefficient of x. Now we need to use the point slope form, and we take our points. X is a -2, y is a -4, and we plug them into the point slope form with the -4 as our slope. And we end up with y minus y1 would be y minus a -4. And when we do a negative in subtraction, we add the opposite, don't we? Whenever you subtract a negative, you add the opposite. So now we have y plus 4 on this side. On this side, we're subtracting another negative. So we got to add the opposite. So now we have a plus 2. And what we can do is distribute this -4 to the x and also to the 2. And we get -4x minus 8. Now, to isolate the y, we can add a -4 to each side of the equation. It eliminates this positive 4 right here. And -8 plus a -4 is a -12. And our new equation that's parallel is y equals -4x minus 12. That's in slope-intercept form. And when we compare the first one, the given one, we had a -4x plus 3, to this one, we can see that they have the same slope and different y-intercept b. See that? Now, did you notice in this one I used brackets, and in this one I just used parentheses twice? It doesn't matter which you use. Both are acceptable. But a lot of people like to use brackets when they're doing this because it's easier on the eyes. See that? But if you're okay with using double parentheses like this, then that's okay. It's acceptable, all right? Okay, just remember, to be parallel, they need to have the same slope m, but different y-intercept b, all right? And our next video is 3.7c, and we're going to talk about how to determine if two lines are perpendicular. I'm going to add this video to the Algebra 2 playlist. You can use it to study or catch up. The link is in this description. And also there's a link to Algebra 1's Chapter 7 Graphs and Linear Equations playlist if you still need to go back and have a little bit more basic tutorial, okay? All right, we're going to talk perpendicular in the next video. I hope I'll see you there. Bye.